All right, welcome to another deep dive. This time, we're going to be looking at AI chips.
Yeah.
Not the ones that are, in like massive data centers, but the ones that are in our devices.
Right.
The ones that are going to be, like right there in our pocket.
Yeah, in our pockets.
And we're going to be exploring this report called Advanced AI Chips for Personal Devices by Jörg-Owe.
Mm-hmm.
And this report really kind of got me thinking about like the future of everything.
Yeah. Yeah, well, it's easy to overlook these tiny components.
Yeah.
But Schnepphat really lays out, like a compelling case for why we should all be paying attention to this.
Yeah, I think so too.
These chips are going to revolutionize how we interact with technology.
Right.
In ways we're only just beginning to understand.
Yeah, I think so too. So before we get too far ahead of ourselves,
Mm-hmm.
let's just break down the basics.
Right.
What exactly are these AI chips and why are they so different
Okay.
from the chips that we're already used to?
Yeah. So think of it this way. The chips that we've had, in our devices for years are like general purpose workers.
Right.
They can handle a variety of tasks.
Mm.
But AI chips are more like specialists.
Okay.
They're optimized for the unique demands of artificial intelligence.
Right.
They process information in a way that mimics the human brain.
Okay.
And that enables things like, facial recognition, natural language processing, even predictive modeling.
Wow. Okay, so Schnepphat talks about a few different types of AI chips.
Right.
Like GPUs, NPUs, FPGAs, and ASICs.
Yeah.
It's like alphabet soup.
Yeah. It is a little bit.
Can you help us kind of like decode each one?
Absolutely. So let's start with GPUs,
Okay.
for graphics processing units.
Mhm.
Now, you probably associate those with gaming,
Right.
and you're not wrong.
Yeah.
But their ability to process massive amounts of data in parallel
Sure.
makes them ideal for AI.
Okay.
So imagine trying to teach an AI to recognize a cat in a photo. It needs to analyze millions of pixels at once to identify patterns.
Mm-hmm.
That's where a GPU's parallel processing power comes in.
Oh, so that's why they're good for that.
Yeah, exactly.
Okay, so my gaming laptop could secretly be an AI powerhouse.
It could be.
That's kind of cool.
Yeah.
What about these NPUs?
Okay, so NTU.
Neural processing units.
Neural processing units, right?
Schnepphat says they're even more specialized.
Yes. So if GPUs are like a team of super fast processors,
Right.
NPUs are like a brain
Okay.
designed specifically for neural networks.
Okay.
Think about how the human brain learns.
Yeah.
It forms connections between neurons, strengthening some pathways, weakening others.
Right.
NPUs are structured in a similar way,
Interesting.
with interconnected processing units that excel at pattern recognition, natural language processing, and making complex decisions based on information.
Okay, so NPUs are like the brains of the operation.
Yeah.
Built specifically for that deep learning that powers AI.
Right.
What about FPGAs? I know Schnepphat calls them like shapeshifters,
He does.
which sounds pretty intriguing.
Yeah, that's a very apt description.
Right.
FPGAs, or field programmable gate arrays, are incredibly flexible.
Okay.
Think of them like a box of Legos.
Right.
You can reconfigure them to perform different tasks,
Okay.
depending on your needs.
Mm-hmm.
So this adaptability makes them ideal for AI applications that require a unique approach or are constantly evolving.
Okay.
Like, say you're developing a new type of sensor that needs to process data in a specific way.
Right.
An FPGA could be programmed to handle that.
Wow. Okay, cool. So FPGAs are like the adaptable ones.
Yeah.
The multi-talented members of the family.
That's right.
Okay, last but not least, we've got these ASICs.
Yes.
What sets them apart?
So ASICs, or application-specific integrated circuits, are the hyper-focus specialists.
Okay.
They are designed for one specific job.
Right.
And they do it incredibly well.
Okay.
Think of it like a master chef who specializes in one particular dish.
Okay.
They've honed their skills, optimized their tools to create that dish faster and more efficiently than anyone else.
Interesting.
Google's tensor processing unit, for example, is an ASIC built specifically to accelerate machine learning.
Oh, okay. So it's like super specialized.
Very specialized.
Okay, so we've got our GPU workhorses, our brainy NPUs, our adaptable FPGAs, and our super specialized ASICs.
Mm-hmm.
It's like a whole team
It's a whole team.
of AI chip superheroes.
Each with their own strengths.
Each with their own strengths.
Yeah.
But how is all of this impacting my life?
Right.
I don't have a Google server farm in my basement.
You don't.
No.
That's where things get really interesting.
Okay.
And Schnepphat does a great job of bringing this technology down to earth.
Okay.
These chips aren't just powering research labs and data centers.
Yeah.
They're increasingly finding their way into everyday devices.
Okay.
And that's going to have a profound impact on how we live, work, and play.
Give us some examples. Paint a picture of how these AI chips are shaping the world right now.
Okay, so take your smartphone, for instance. With the power of AI chips, it can become so much more than just a communication device.
Okay.
Imagine your phone acting as a personalized health advisor, constantly analyzing your vitals and alerting you to potential issues.
Oh.
Or picture a world where augmented reality is seamlessly integrated into your life.
Okay.
Thanks to AI chips processing massive amounts of data on the fly, making those virtual experiences feel real.
Okay, now you're talking.
Right.
Yeah.
No more lag.
No more lag.
When you're trying to catch that Pokemon.
Yes.
AI chips mean faster response times.
Right.
Smoother user experience.
Yeah.
And a level of personalization we've never seen before.
Okay. Yeah, I'm liking this.
But there's another huge benefit that Schneppat highlights.
Okay, what's that?
Data privacy.
Okay, everyone's worried about that these days.
Right.
Their data being collected and shared.
Exactly. And here's the thing.
Okay.
AI chips can actually enhance privacy by enabling on-device processing. Instead of sending your information to the cloud for analysis, it can be processed right there on your device.
Okay, that makes sense.
Keeping it safe and secure.
So my data stays with me.
Exactly.
Okay, huge relief.
Yeah.
Okay, so I'm officially sold on the why should I care front.
Okay.
But Schneppat also mentioned some pretty impressive numbers when it comes to the growth of this market.
Yes.
Something like $91.96 billion by 2025.
Wow.
That's a lot of chips.
It is, and that growth is being fueled by a few key factors.
Okay, like what?
First, the demand for smarter, more capable devices is exploding.
Right.
We want our phones, our cars, our homes to be more intuitive and responsive.
Yeah, we basically want them to do everything for us.
We want convenience.
Yeah, it's true.
And second, the machine learning models that power these AI applications are becoming more and more complex.
Okay.
They need more powerful hardware to keep up.
Yeah, that makes sense.
So it's a bit of a chicken and egg situation. More powerful chips lead to more complex AI, which then requires even more powerful chips.
So it's like an arms race.
In a way, yeah.
But it's not all sunshine and roses, right?
Right.
Schneppat also dedicates a whole section to the challenges of this technology.
He does.
Like, how do you keep these powerful chips cool?
Yeah.
They must generate a ton of heat.
That's a big one. Thermal management is a serious engineering challenge.
Right.
These chips are doing a lot of heavy lifting.
Right.
All that processing power generates heat.
Right.
If you don't manage that heat effectively, the chips could overheat and malfunction.
Yeah, that makes sense.
So engineers are constantly working on ways to keep them cool.
So it's like building a tiny, super efficient engine.
Yes.
And then figuring out how to keep it from melting.
Exactly.
What are some of the other challenges that Schneppat highlights?
Well, on the software side,
Okay.
we need to make sure that operating systems and applications can actually use these new chips effectively.
Right. It's no use having the engine if the car can't handle it.
Exactly. So developers are working hard to create software that can fully utilize the capabilities of these AI chips.
So it's like building a race car and then teaching people how to drive it.
That's a good analogy.
Okay, and then there's that constant balancing act between power and performance.
Right.
Especially for mobile devices.
Yeah.
We want our phones to be incredibly smart and responsive.
Yeah.
But we also want them to last all day.
All day on a single charge.
Exactly.
That's right. Finding that sweet spot between power and efficiency is a constant challenge.
Okay, so with all these challenges, what does the future hold?
Right.
Where are we headed?
That's where things get even more interesting.
Okay.
Schneppat outlines some key trends to watch.
Okay.
And they paint a pretty amazing picture of what's to come.
Hit me with them. I'm ready for more.
Okay, well, first, expect to see even more specialized AI chips designed for very specific tasks.
Okay.
Think chips optimized for natural language processing or image recognition or even specific types of medical diagnostics. Instead of a one-size-fits-all approach, we're moving towards a world of specialists.
Okay, so instead of having one chip that does a little bit of everything,
Right.
we'll have a whole team of chips, each with their own expertise.
Exactly.
I like it.
And another big trend is the shift towards edge AI,
Okay.
where processing happens on your device, not in the cloud.
Oh, okay.
This has huge implications for privacy, speed, and reliability.
That makes sense.
Imagine a world where your phone can make complex decisions without needing to connect to the internet.
Wow. Yeah. Who needs the cloud when you've got all that power
Right, in your pocket.
in your pocket? That's right. And then there's the potential for customization.
Mm-hmm.
Imagine chips that are tailored to your individual needs.
Right. to you.
Like a personal AI assistant that knows you better than you know yourself.
Knows you inside and out.
Okay, now we're talking sci-fi.
Right.
But it's not that far-fetched.
Not as far-fetched as you might think.
Is it?
But here's the key takeaway from Schneppat. This is a rapidly evolving field, full of possibilities and challenges. We're still in the early stages of understanding the full potential of AI chips.
Right.
But one thing's for sure, they're going to change our world.
In big ways.
Big ways.
And we're along for the ride.
Yeah.
But we've only just begun our exploration.
This is just the beginning.
Stay tuned for part 2.
Right.
Where we'll delve deeper into the economic forces driving this AI chip revolution and explore the role of key players like NVIDIA and Qualcomm.
Yeah.
Even Apple. It's going to be fascinating.
It is going to be fascinating.
So grab your headphones, charge up your AI-powered devices, and get ready for part 2
of our deep dive
into the world of AI chips.
See you then.
See you soon.
Welcome back to our deep dive into the world of AI chips. In part 1, we explored all the different types of AI chips, and how they're already making their way into our devices. But as Jörg-Owe points out in his report, this isn't just a technological revolution.
Yeah, it's an economic one too. It really is. So the AI chip market is booming. There's some major players in the game.
Yeah.
So let's kind of break it down. NVIDIA, that's the name everyone's talking about these days.
Right, they're everywhere.
They really are. So what makes them such a dominant force?
Well, NVIDIA has become almost synonymous with AI chips, particularly for their GPUs.
Right.
Which are used not just for gaming, but for complex AI tasks like deep learning.
Right.
Schneppat notes that they currently hold a 95% market share.
Wow, 95%. That's incredible.
It is.
What's their secret? Why are they so far ahead?
Well, their GPUs excel at parallel processing, which is essential for handling the massive amounts of data involved in AI.
Right.
Remember when we talked about teaching an AI to recognize a cat in a photo?
Yeah.
That requires analyzing millions of pixels simultaneously.
Right.
NVIDIA's GPUs are designed to handle that with incredible speed and efficiency.
And Schneppat really emphasizes that NVIDIA is constantly innovating.
Yes.
They're pushing the boundaries of what's possible.
Yep. They're not resting on their laurels.
No, they're not. They're not just counting their money. They're actively investing and trying to stay ahead of everyone else.
Absolutely.
Okay, so what about Qualcomm?
Yeah.
I know them for their Snapdragon chips.
Right.
That are in like a lot of smartphones. How do they fit into this?
So Qualcomm is a major player in the mobile space.
Okay.
And their Snapdragon processors are already powering a lot of the AI features that we use every day on our phones. Think of these chips as like mini AI powerhouses, combining CPUs, GPUs, and specialized AI engines all on a single chip.
It's like having a little tiny brain right in your pocket.
Exactly. It's pretty amazing.
Yeah, it is. And this is what's enabling those features like on-device AI processing.
Right.
Which, as we said before, is a huge deal for data privacy.
Absolutely.
Keeping everything on your device rather than in the cloud.
Exactly. And Schneppat points out that Qualcomm is really focused on making AI more accessible and affordable, bringing its power to a wider range of devices and applications.
So it's not just like the high-end stuff anymore.
Right.
We're seeing it integrated into smart home devices and even wearable technology.
That's right.
Okay, but Schneppat also mentioned this company, ASML.
Yeah.
And ASML is not a chip maker.
No, they're not.
But they play a critical role in this whole thing.
They do. They're essential.
Yeah. So what do they do?
ASML is the world's leading manufacturer of lithography machines.
Lithography machines, okay.
These machines are the tools that make it possible to create those tiny circuits on the chips.
Oh, wow.
The pathways that allow them to function.
So they're kind of like the master craftspeople.
Yes.
Who provide the tools for the AI chip revolution.
Exactly. And what's fascinating is they have a virtual monopoly on this technology.
Wow, really?
Without ASML, the entire AI chip industry would stop.
Wow, they're in the right place at the right time.
They are indeed.
So it's not just the established players like NVIDIA and Qualcomm.
Right.
Schneppat mentions that even Apple, a company known for its like tight control.
Yes, very controlled.
Over its hardware and software. They're even getting into this.
They are. Apple is increasingly investing in its own custom AI chips.
Oh, really?
Designed specifically for their devices.
So they're not even going to Qualcomm anymore.
Well, they're doing some of both.
Okay.
But they're bringing a lot of it in-house.
So you can really kind of tailor the chips.
To their specific needs.
To their exact needs.
And create that seamless integrated user experience.
Right. Optimize it.
Exactly. They want to create a closed ecosystem.
Yeah, that's a smart move.
Very smart.
But all this talk about, market dominance and economic forces.
Yeah.
It's exciting, but it also raises some questions.
Of course.
Is this level of consolidation healthy for the industry?
Right.
What about the risks associated with these increasingly powerful chips?
Those are valid concerns.
Yeah.
And Schnepphat acknowledges that there are potential downsides to consider. As AI chips become more powerful and ubiquitous, we need to think about the ethical implications and ensure that this technology is developed and deployed responsibly.
So it's not just, rosy predictions and everything's going to be perfect.
It's not a utopia.
It's not. Okay.
There are challenges.
There are challenges.
There are potential risks.
That we need to address.
And that's what we're going to delve into in the final part of our deep dive.
Okay.
We'll explore the need for ethical guidelines.
Yeah.
The potential impact of AI on jobs and society.
Okay.
And what we can all do to ensure that this technology benefits all of humanity.
That sounds like a conversation we need to have.
It's an important one.
So stay tuned, everyone, for part 3 of our deep dive.
The final part.
Into the world of AI chips. We'll be right back. Welcome back to the deep dive. We've covered a lot in our exploration of AI chips, from the different types and their capabilities to the economic forces shaping the industry. But as Jörg-Owe reminds us in his report, we can't just focus on the what and the how of this technology.
Right.
We also need to think about the why.
That's right. As we enter this new era of AI-powered devices, we need to think about the values that are driving the development of these chips. Are we simply chasing, faster processing speeds and greater efficiency?
Right.
Or are we considering the broader societal implications?
Right. Were you thinking about the impact on people?
Yeah, the impact on human lives, the future we're creating.
Schnepphat seems particularly concerned about the potential for these AI chips to exacerbate existing societal inequalities. If we're not careful, this technology could end up benefiting a select few and leaving others behind.
That's a very real concern.
Yeah.
And it's something we need to be actively working to address.
So how do we do that?
Well, Schnepphat points out that AI chips are often trained on massive data sets.
Right.
And these data sets reflect existing biases in our society.
Yeah.
So if we're not careful, those biases can be baked into the very hardware that's shaping our digital experiences.
So it's not just about making sure the algorithms are fair.
Right.
It's also about the data that's used to train these chips.
The data is fuel.
Yeah, and how that data can perpetuate these inequalities.
Exactly. And we need to think about who has access to this technology.
Right.
And who benefits from its development. If AI chips are primarily used to automate tasks that displace low-wage workers while creating new opportunities only for highly skilled professionals, that could widen the gap.
Yeah. Between the haves and the have-nots.
It's a complex issue.
Yeah.
But it's a conversation we need to have now.
Now, before it's too late.
Before this technology becomes so pervasive that it's too late to course correct.
So where do we go from here?
Right.
What can our listeners do to engage with these issues and help shape the future of AI?
Well, first and foremost, stay informed.
Okay.
Read articles. Listen to podcasts.
Like this one.
Like this one, exactly. Yeah. And engage in conversations about the potential benefits and risks of AI chips. The more we understand about this technology, the better equipped we'll be to advocate for its responsible development.
Knowledge is power.
Right. What else can we do?
Yeah, what else can we do?
Support organizations that are working to promote ethical AI development.
Okay.
There are a number of groups out there pushing for greater transparency, accountability, and fairness in the AI industry. Your support can make a real difference.
So vote with your wallet and your voice.
Exactly. And most importantly, don't be afraid to ask questions.
Yeah.
Challenge the status quo, demand better from the companies that are developing this technology.
Yeah. We have a voice.
We do as consumers and as citizens.
Right. We have a voice in shaping this future.
That's right. The future is not predetermined.
Right. It's up to us.
It's something we create collectively through our choices and our actions.
Well said. I think Jörg-Owe would agree with that his report is a powerful reminder that the future of AI is not just about technological innovation.
Yeah, it's about more than that.
It's about human values and ethical considerations.
Right.
Our shared responsibility to shape a future that benefits all of us.
Absolutely.
Thank you for joining us on this deep dive into the world of AI chips.
It's been a pleasure.
We hope you found it informative and thought-provoking.
Yes, and maybe even a little bit inspiring.
Inspiring as always, the conversation doesn't end here.
It doesn't. Keep exploring, keep asking questions, keep engaging with this fascinating field.
We'll catch you next time on The Deep Dive.